All right, so if you have not done so already, go ahead and respond to the online poll, okay? To let the attendance poll let me know that you're here. And then, if you ever arrive late or whatever, tell your neighbors who get here a little bit late that an attendance poll is running and they should log in and tell me that you're here. I saw on Piazza some people talking about some of the issues that they face with the notes that I post and people wanting to make PDFs out of them and things like that. So let me just kind of address some of those things, okay? So sometimes, depending on, the CCLE settings, sometimes you click it and it will download a file. Sometimes you click it and it loads as like a text file and things like that, okay? And in either case, it shouldn't derail you too much, okay? So you can just open this and it will open as an RMD file. But if you open click the link and it loads up as a text file, fear not, it's easy to work, okay? All you have to do is just go to RStudio and just create a new file, right? So you can do new R Markdown file. Okay, so you go ahead and click new R Markdown file. Just click OK. It doesn't matter. You can just leave it as document HTML. All those settings do is just change stuff in the header, okay? But it doesn't matter. Just create a new R Markdown document. Delete everything that's in there, okay? So you Control A to highlight everything and you hit delete, okay? And you guys should all know that shortcut. Command A for all, Control highlights everything, and delete, okay? So sometimes you just need to wipe out something. Control A, delete, and then you'll come over to this thing that looks like a text document, and you'll hit Control A to highlight everything, and then copy and paste. Control A, Control C, or Command C, and then Control V, okay? And so that pastes everything into the R Markdown document. And then, so even though when you clicked it, it said HTML document, now that it says output IO slides presentation, it's gonna render it as the format that I have. So you go ahead and you click knit. It'll say, where do you want to save this? So you're save it somewhere. So I'll call this lecture 2-2, week 2, session 2. And R will take its time to knit it. And now you have the document notes, okay? And you can click open in browser and follow along if that's what you want to do, okay? So don't be too put off. I hope you're not too put off that when you click this, sometimes it shows up as a text file. All you have to do is just copy everything, Control A to highlight everything, Control C to copy it, and then you come over and you paste it into a new document to make it, right? You can, if you want to make a PDF out of it, okay, you can click the little drop-down menu next to the knit button and click knit to PDF, okay? Now, that wasn't my intention when I did this, but it's certainly an option. And now you'll have a PDF that, as far as its style sheet goes, looks a little bit different, but as far as the content goes, all the content's exactly the same. LaTeX usually takes a little bit longer to render and generate documents, and sometimes for whatever reason it'll just crash, okay? And LaTeX, I don't know, LaTeX is very picky about all of the things it can do, and you need to have packages loaded here and there and blah 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 blah, okay? But all of this stuff is there. But another thing you can do, okay, is you can just delete the thing. So when you download it, it's gonna say IO slides presentation here under output, okay? And this is how it'll download. But you can just change the output from IO slides presentation to something like HTML_document, okay? And you click HTML document and you click knit, and it will convert it into an HTML document. You can also do PDF document, and I think even Word document. All of these things you can do PDF document and have PDFs, okay? Now, I know I love PDFs, and I know you guys love PDFs, but I don't post my notes as PDFs, okay? And the reason for that is because PDFs are difficult to edit, all right? You can write on top of them. They'll have all these apps where you can add like notes and stuff on top of a PDF, but as far as editing a PDF itself, it is like impossible. If you don't have that font loaded onto your computer, when you edit the PDF, it's gonna look funny afterwards, right? So PDFs are just like, they're not made to be edited. They're only made to be like written on top of. And maybe that's what you want. But I will continue posting everything as our markdowns because I am a big fan of Markdown, if you have not noticed or figured that out. So if you don't want it as an IO Slides presentation, and I get that, okay, it's useful for presenting stuff in class, but not so useful for taking notes, just come here, change this to HTML document, okay? And then, because it's a Markdown file, it's very easy to enter. So as you're sitting in class, I might say something and you say, oh, I want to take note of that. You can just type directly into the Markdown document, right? So here, you know, this first slide says order integer subsetting, and maybe you want to add something like this topic is stupid or something, right? Whatever. This topic is great! Exclamation points. Okay, and then and you want to include that, you can just type that in there, and then when you knit it, you know, your commentary that you've added will show up immediately in the document, right? And if you want to somehow distinguish the stuff you've written, right? So here it is right there, from the stuff I've written, you can emphasize it using asterisks, okay? So double asterisk will suddenly turn things bold, and you can knit these things and whatnot. And then, you know, once they're in an HTML thing, then you can like print it out and stuff, and your stuff will appear right here, okay? And so this allows you to take notes and add stuff, and in fact, if you wanted to add your own code example, it's very easy to do that, okay? Versus trying to have a PDF and write code using your, you know, maybe you've got like a iPad Pro or something, and you can write with a pen, or a Surface tablet, and you can write with pens and stuff, and that's a nice feature, but you know, trying to write code or add things to it manually is not so fun. All you have to do is in the R Markdown, just add a code chunk. And I think you guys know this shortcut, right? Control Alt I, or Command, is it Command Option I on the Mac? Okay, and that will insert code chunks into the thing, and you can add whatever it is that you want. Okay, and so every quarter students ask for PDFs, but my answer is always no. I'm going to keep posting R Markdowns, and you will learn to love it. Okay, so. And if you've ever tried to make a PowerPoint presentation that includes code chunks in it, you know how frustrating it can be, because when you copy and paste stuff from R into a PowerPoint, like PowerPoint will do like auto formatting, right? It's going to suddenly capitalize the first line of every code, and that's frustrating because you're like, I don't want a capital C, or I don't want a capital D, okay? Or you can use, you have to set the style sheets for pre-formatted text and stuff like that. It's frustrating, but you know, making presentations using R Markdown is a lot more of a natural and smooth process. So if you ever have to make a presentation that includes some code chunks and code output, I highly recommend considering just doing it straight within R Markdown. Now, there's a few things you give up, okay? It's very difficult to choose any kind of, you have no control over the layout, right? You can't just drag things and say, I want my picture here and stuff over here. That's not possible. It's just gonna put everything in kind of this linear flow. But as far as taking code and outputting them and putting them up on the screen, I think it's great. Okay, so anyway, let's do this. Okay, so we'll go ahead and knit my presentation, and we'll pull that up. And I included these slides, but I don't want to. I'm going to skip over some of these, or a bunch of these things actually. Okay. So these were in the other notes. Okay, highlights of subsetting applications, and you've got ordering and removing columns from data frames and selecting rows based on a condition. I think the notes are straightforward enough that you can figure it out on your own. So I'm going to skip over those. Boolean algebra versus sets. This topic, the most important function to talk about is which is a very useful thing. It takes a logical vector of true false values and it turns it into an integer representation indicating the indexes or indices of the values that are true. Okay, so here I've got shuffle the numbers 1 through 10, so that's what we have, sample 10. Shuffle the numbers 1 through 10, which values are less than 4, okay? And it just so happens that when I shuffled these, the values at index 4, 5, and 6 are true, okay? And so when I did that, the values at index 4, 5, and 6 happen to be true, and so which returns 4, 5, and 6, okay? You can imagine how this can be played to be useful in some kind of, maybe you have a data frame, and one of the columns is a categorical variable, okay? So maybe it is the color of a car, right? And you got red cars and silver cars, white cars and black cars, and I don't know, other colored cars. And maybe you're just curious, and maybe you've got 1,000 entries in this data frame. So you've got 1,000 rows, and let's say 50 of those cars are red, okay? And so you can do data frame $color equal to red. Okay, so that'll be, and that will return a true-false vector, which will be, true for the cars that are red, false for everything else. Okay, how many entries are in that true-false vector? There's going to be a total of 1,000 because you're going to have a true or false value for every person or every row in that data frame, which maybe has 1,000 rows, okay? But if you take which and you say data frame $color equal to red, then it will return the indexes or indices of the rows that have red cars, okay? And so it'll say row 23 has a red car and row 107 has a red car and row 124 has a red car, things like that, okay? And that's very useful because you might not want a true-false vector. With that, you want just the indexes, and then you can do stuff with that. So the which function is very, very handy and very powerful. So here's just a couple examples relating which and set operations with logical operations, okay? So here I've got x1 is a logical vector where every other value is true and every other value is false. So it goes false, true, false, true, false, true, false, true. Basically, it's true where mod 2 is equal to 0. So true for the even values. If I feed x1 into which, it says 2, 4, 6, 8, and 10 are true. Over here, I've got mod 5 equal to 0, so it's going to be everything except the 5th and the 10th elements are false. So element 5 and element 10 are divisible by 5, so they are true, and everything else is false. And if I throw that into which, I get 5 and 10. Okay? So x1 and y1 are the logical vectors, x2 and y2 are the integer vectors. Is that okay? And so let me just show you some combinations of things. So here's the logical operator, the x and y, okay? And so if we take the logical vectors and we do an AND operator, it's going to return true only when both vectors contain true, okay? Which it's only true for the last thing, okay? That's equivalent of doing the intersection for a set operator, okay? So you can imagine the circle over here and the circle over here, and only the intersection, that football shape in the middle, will be returned, and that's the 10, right? So what's divisible by 2 and what's divisible by 5? 10, okay? On the other hand, you have or. Or will return true if either thing is true, okay? And so that's going to be, as far as the Venn diagram, that's going to be everything together, okay? So what's divisible by 2 or divisible by 5? Basically, all the even numbers, 2, 4, 6, 8, 10, and 5 are all divisible by 2 or 5. So that's equivalent to a union. And then these ones are a little bit more fancy, right? X and not Y, okay? This is set difference, X and Y. And so if you imagine this circle and this circle, it's basically the moon-shaped thing that has X but is not overlapping with Y. Okay, so that's set difference, or X and not Y. And then the exclusive or is what's in X and what's in Y, but is not in common to either of those. Okay, so that's the exclusive or. So basically, what is divisible by 2 or 5, but not divisible by both. Okay, and that's 2, 4, 6, 8, and 5. So in the Venn diagram, it's this moon shape and this moon shape, but not the football in the middle. Okay, it makes sense in my brain, but okay. But anyway, that's what we've got. So these, it's the set difference of the union and the intersection. So, but anyway, don't worry about it. Okay. And here's a few extra commentary. Just review that when you go through your notes. All right, now we can talk about some programming basics, okay? And so last week we talked about a lot of kind of data structures, and your first homework assignment kind of covered a lot of the nitty-gritty of some data structures, and asks you about the difference between cat and print, and what happens when you do this with a factor and stuff like that. And this week, we're now going to start doing things that are a little bit more programming intensive, okay? And you're going to have to start writing actual code, not just answering questions about what these operators in R do. And so in discussion section, I tried to ask the TAs to kind of cover some common errors that people will encounter, and that I hope that will help you as far as in your coding, because probably you will encounter errors in your code and you'll need to be able to debug them. And so here we'll start talking about the basics of some programming work, okay? So let's talk about your working directory here, okay? When you start R, and if you ever reference a file, like you want to load in some data, okay, R is going to look in the working directory. And so to kind of, what I recommend is that whenever you open up a file, go to session and do set working directory, and then choose to source file location. So this says, I've opened up this file and I want to set this as my working directory. And then when you reference anything else, like data.csv or something like that, as long as data.csv is in the same directory as this current file, R will find it because it'll search the working directory. What you don't want to do, okay, and this is all too common, is don't download your homework file into your downloads folder and then open it up directly in your downloads folder and then set your downloads folder as the working directory, right? Because chances are, if you've had your computer for longer than 2 days, your downloads folder is full of hundreds of, I don't know, a bunch of junk in there, okay? Your downloads folder gets really cluttered very quickly. I don't know, you're saving pictures of whatever and jokes and things like that. So download the homework file, move it into, you should have some kind of organization system on your computer somewhere, right? Your school folder for this class, Stats 102A. Move it over there, probably create a homework folder for homework 1 or homework 2 or whatever. Put it in there, open it up, set that as your working directory, and then if you have data files, put that in there as well, okay? Otherwise, it's gonna get too messy. If you ever plan on opening a file on another computer or working with anybody else, when you set a working directory, you should never point to something that's directly on your own computer. So you can use this command set working directory to some location on your computer directly, but it should never include something like users/miles, because obviously if I gave you this thing and it says we're looking for the folder users miles, you should not have that folder on your computer, right? Unless your name happens to be Miles also, but that shouldn't be the case. So don't do that, okay? As you work, you will create items, and they will appear in your environment, right? So you're working along, and A is going to be 1 through 100, and B might be like which values of A are divisible by 3 and things like that, and you create all of these values inside your environment, and you can always ask, well, what is in my environment, okay? And you can do that by typing ls, and that will list off everything that's in your environment. Or in RStudio, you just go to the Environment tab, and it will show you what's in the environment, okay? So this actually, because this thing exists, I hardly ever type ls anymore, okay? But before RStudio came along, and RStudio is only an innovation in the last 5 years or so, we had to type ls all the time to see what was in there. And I highly recommend that when you start anything new, you delete everything in your current environment, okay? So you can do this by doing rm list equals ls, okay? That's one way to do it. Probably easier, again, with RStudio. Just click the little broom, and this will sweep, clear out your entire environment, and it will do that, okay? And so it'll say environment is empty, and when you ask ls, it's going to say I've got a 0 length character vector. There's nothing in there, okay? I like in my thing, I like to have .last value show up in the environment, and this is, I forget, I did this somewhere in one of my options as far as show .last value in environment listing. I like having that in there, but whatever. Okay, another thing is I highly recommend changing one of your global options to on this thing that says save workspace to R data on exit, save that as never, okay? And this will force you to start getting into the habit of working with an empty environment when you start up R, okay? And if you ever want to save files that are or objects that are in your environment, you can do that. You just click the the save icon, and you can explicitly save the environment. But to get in that, if you are referencing, if your folder references items that exist in the environment that don't exist, that aren't created within that file itself, and you ever give that file to someone else, it's going to cause problems, right? So, if you ever plan on working with somebody, okay, which is going to be all of you if you're ever employed, because you're going to be working with other people, it's not good to reference things that exist only in your environment. So get in the habit of starting with an empty environment, and one of the things that does that will be setting the global option to never save your current workspace when you exit, okay? Because the default is to save your current workspace and then load it back up when you start R again. Just get in the habit of always kind of clearing it out. when you render a file, okay, when you click knit in on our Markdown file, R always starts a brand new session with nothing, no objects loaded into it, okay? And so sometimes you will encounter mistakes because somewhere along the way, maybe you comment a line out or you forget that you've created an object. And so, for example, my very first code chunk in this thing creates an object called X with the letters B, C, and A in it, okay? And so if I comment this out, X is not created, and then the first line of code that R tries to run is going to be, give me back the order of X. And it says, X is not found, okay? It gives you an error. It says line 17, error in order X, okay? This line 17 is not the location of where the error actually exists. It's the location of the first line of the code chunk where the error exists, okay? So here it says there's a code chunk, there's an error in the code chunk that begins on line 17, and then here it says error in order X, object X not found, okay? And the reason why is because X was never created in this thing, all right? A lot of times people post on Piazza and they'll say, I am able to run the code on my computer because maybe somewhere in their work they created these objects, something like this, okay? And so X exists in their environment, and then when you execute this code, it seems to work just fine, okay? And you go, well, the code works just fine on my my computer. Look, I'm able to run this. There's no problem. And then, but when I try to knit it, it's giving me an error, and they can't figure out what's going on. Okay. The reason why is because their environment has stuff, but then when you start a new session and you clear out the environment, this object X does not exist, right? So one thing that you can do in the debugging process is you'll say, all right, let me try clearing out my environment, starting off with an empty environment, and then I'm going to try running my code chunks. You delete your entire environment, you run this code chunk, and then you go, oh, I am now encountering an error, object X not found, okay? And then you say, oh, well, that's because in my code I commented out the line that creates the object X, okay? And then so now you can just say, all right, well, let's try to run this, and now it works. And now I'm able to knit this thing, okay? So this is a common thing that people encounter, especially when they're trying to turn in their homework. They try to click knit and the thing doesn't knit. And a lot of times it's because, and then they'll say, it runs fine, I'm able to run all the code, but when I knit it, it doesn't work. A lot of times it's because objects exist in the environment that aren't being created in the script itself or the Markdown file itself. And when you click knit in the Markdown file, it starts off with a fresh environment with nothing defined in it. Okay, and so you should get in the habit of starting with a fresh environment with nothing in it, and explicitly creating all of the objects that you're going to work with yourself. Okay. So anyway, that's what we have. Adding comments to your code. So I'm just trying to indoctrinate you on certain good practices. So anyway, I think you guys know how to add comments using the hash mark. There's a keyboard shortcut which is very useful. Okay, it's Control-Shift-C or Command-Shift-C if you're in a Mac. Okay, and you can just do that, and it toggles whether the lines of code are comments or not. You can highlight multiple lines of code, and it will toggle the entire block to be a comment or not. Okay, which is very useful, especially if you just want to turn off a certain chunk of code so it doesn't execute. You can hit Control-Shift-C, Command-Shift-C, and it will toggle that. Get in the habit of writing everything in a script rather than directly in the console. Okay, a lot of times you will write. Okay, so another thing that students do is they'll write commands directly in the console, and then later on they'll try to execute their RMD or their script, and that code that they wrote in the console does not exist in their thing. And so, you know, if they create an object in the console or something, get in the habit of writing things in scripts or the RMD files. Okay, now should you create an RMD or a script? Scripts should be used if the thing is mostly code. RMDs should be used if the thing is mostly a document where you're talking that happens to include code. Okay, so in the homework, I present everything as RMDs because a lot of it is me just giving you instructions and asking questions about, like, do this and do that and do this and do that, and then you answer it with a little bit of a code chunk. Okay, this week, I'll post up the second homework assignment, and in that you're going to have to write a tic-tac-toe game. Okay, and when you do that, write an R script. Don't create your entire tic-tac-toe game within the R Markdown file. Okay, write a R script because that's going to be mostly code, and you'll execute that. Okay, so do that. Okay, and now we can start talking about the way we power our scripts. Okay, so the first thing to talk about are conditionals. Conditionals are things that say, if this is true, then do this. Okay, and this is how we all work in the world anyway, right? If you look at someone and the person is smiling, you know, you smile back. If you look at someone and the person is not smiling and looks angry, you know, you look away and you avert your eyes or something like that, right? So this is just, you know, we operate. I don't know about operate, but you know, we usually if we operate kind of on conditionals and similar. The computer operates on conditionals, and I mean, there's a whole question of, you know, do we even have free will? But that's not the point of this class. So, because maybe we're just subject to the internal programming of our brains that are just the results of the sequence of life events that have happened to us. But let's talk about these logical operators. And we have vertical bar for or, and ampersand for and exclamation point for negation. Okay, these are all vectorized, meaning you can give it a vector of logical values, true, false values, and it will run down these element-wise, recycle them if necessary. The double or, the double and, these are not vectorized. We also have the exclusive or. We'll talk all about these things. Okay, so the single ampersand and the single bar, these are vectorized. The doubles are not. Okay, the vectorized ones will perform recycling if they need to. The non-vectorized ones only look at the first element of these things. Okay, exclamation point is for negation, so it's going to just give you the opposite of what it is. Okay, and if you have numeric values and you combine them with an operator like this, it's going to coerce that numeric value into a logical value. So you can do something like not 8, and what will this return? This feels weird. You shouldn't do this in your code, but you can. Okay, so not 8 will return false. Okay, what's going on is if you do as.logical 8, what will as.logical 8 do? It coerces the numeric value into a logical value. Okay, anything other than 0 will be true. Okay, and then say if you say not 8, it's going to give you the opposite of true and give you false, right? So if you say not 0, then that will be true, but you know, even things like not -1, I mean, these are, don't do this, okay? But this is also why if you have a true false thing, right? So if I've got true, false, false, and I say or something like that, it's going to coerce the 4 into a true and now everything becomes true. Okay, so these are just, don't do stuff like that. All right, so here's some examples, okay? I've got this vector, true, true, false, false, missing, missing, okay? And y is false, true, true, false. I should have probably switched the order there. And so if you do the OR will return true if x is true or y is true or both are true, okay? So true, false gives true, true, true returns true, false or false will be false, false or true is true. Missing or true is true, right? Because we have a missing value and a true value over here, and we say, are either of these true? Yes. Okay. Missing along with a false, and we say, are either of these true? The answer is, I don't know. Okay, the answer is, I don't know. With the and, both of them have to be true, so this will be true, false will be false. True and true will give true, false and false will give false, false and true will give false. Missing and true will give a missing value, missing and false will give a false, okay? Because you say, the missing and true, are both of these true? I don't know, okay? If we have a missing and a false, and I say, are both of these true? We for certain sure know that they are not both true, because one of them is false. Whereas the non-vector, the double, only looks at the first element. So it'll say true, false, and gives true, and true, false, and it gives false for the and. Okay, so the double only looks at the first element, which is what we want to use in if statements. If statements can only accept one value in there. XOR is the exclusive OR. This is one has to be true and the other has to be false. Either X is true and Y is false, or Y is true and X is false, okay? It can't be, if both are true or both are false, the exclusive OR will return false. So you've got true, false, true, true, true is false, false, false is false, and false, true is true. And then when you combine it with the missing, then the answer is I don't know, or it's missing. Any and all are generalizations of the OR and AND values for vectors that contain more than two true, false things, okay? So here I've got U, V, W. U is all true, V is a mix of trues and false, and W is all false, okay? And if you run any on these things, it returns true for the one that's all true. It also returns true for V, okay? Are any of these values true? Yes, that's true. For W, are any of the values false? No. I mean, are any of the values true? No, okay? And meanwhile, the all, basically, all of them have to be true. Are all these values true? That is correct. Are all of these values true for V? No. Are all of the values true for W? No. Okay, so you have the generalizations with any and all. When we're dealing with numbers, now we can do these comparison operators, and you learned all of these in second grade. You know, less than and greater than, less than or equal to, greater than or equal to, and these are they equal, and you know, are they not equal? And then you also have this in operator. This is kind of like a set operator thing. Is X in contained in Y? And that's what we have. Okay, so we throw all of these with if statements, okay? So an if statement will be if, and there's some kind of logical statement, and it expects to get a true or false value back, all right? It will, if you give it an NA, a missing value, you're going to get an error. If you give it a thing that has more than one true false value, it's only going to look at the first value in there, okay? And then you use a curly brace to kind of group the expressions that follow the if statement, and these are the lines of code that will be executed if the if condition is true. All right, so over here I've got X is the vector that has the values 1 and 3, and we have this logical statement, is 1 contained in X, and that is true. So if I put that here, if 1 is in X, which is true, print hello, okay? And because I only have one line of code, I actually don't need the curly braces. If you have more than one line of code, you need the curly braces. So because this is true, it prints hello, and when I execute it, that line gets printed, okay? Over here, I've got if x, we ask, is x greater than or equal to 2? So it's going to be false, true. And when we throw that into the if statement, it's going to say if x is greater than or equal to 2, it sees false and it sees true, but it only uses the first value here. Okay, and so it's going to see the false, and so it does not execute this line that says hello again. Okay, so that's not executed, and it also gives me a warning. It says, I was expecting only one logical value, and you gave me something with a length greater than 1. So it gives you a warning. The condition has a length greater than 1. It doesn't error out. The code has run without errors, but it does say this is not what I'm used to. I'm used to only getting one logical statement here. Let me just kind of switch this around so it becomes true false. Okay, so here I've got is x less than or equal to 2, and so that gets true false. Okay, and again here it only sees the first value, the true, and because of that it executes this line of code. All right, so it says, you know, here's a warning, but I've run it and I've executed the line of code for here. Okay, and that's just because it looks at only the first value, and when it's true, it executes that line of code. So if you've got something where you've got more than one true or false value, what you should do is you should throw that statement into kind of an any or an all. Okay, so an any or an all will take all of these things and just say they're all true, or any of these things are true, whatever you applies in your situation, and then this will work here. Okay, if any of the values are greater than 2, then execute this code, and it does. Okay, is that good? All right, we can nest conditionals, right? And this is the combination of the if, the else if, and the else, okay? When you do this, you have to use curly braces, and the else has to be on the same line as the closing curly brace. And this tells R that the if statement is not done, because, you know, over here, it just looks at one line of code and it thinks this code chunk is done. But here, you need to put the else on the closing curly brace, and then it'll say, okay, I've got more work to do. All right? And so here I've got if x is less than 0, print negative. Otherwise, check if x is greater than 0. And if it is, print positive. Otherwise, print 0. So we put in 3, and it gives false. This is true, so it says positive. If I have 0, this is false. This is false. And so it runs just the last statement, the last else, which says print 0. If I nest a conditional here, okay, so here I've got if x is greater than 0, put positive, and if it's bigger than 1, print bigger than 1, okay? The thing is that once this thing is true, okay, if x is greater than 0, once that first statement is executed because it's true, it's going to ignore all of the else's. The else's are only triggered if the first condition is false, okay? Or if the previous condition is false. So when if x is 3, x is greater than 0, that's true. X is also greater than 1, this is also true, but this line will not be executed because this statement is true, all right? And sometimes students will nest their conditionals inside each other, or even professionals will nest their conditionals inside each other and make a mistake in that there is never going to be a situation where this statement is true, but this statement is false, right? There's no number that exists that is greater than 1, and at the same time, x greater than 0 is false, okay? And because of that, this line of code, bigger than 1, will never be executed, because the only way it can be executed is if this statement is true, but it has to trigger the else, which means this statement up here has to be false. Okay, and that's never going to happen. So you just have to watch out for setups like that. Okay, in your tic-tac-toe assignment, part of the job is to figure out when the game is over and who won the game. Okay, and students often make mistakes in having these nested conditionals where it's searching for like maybe x1 or o1 or whatever, but it's nested in a way that, you know, one of the nested things is never going to be executed because it's only true if the, you know, previous statement is true or something like that. Sometimes in a if-else statement, you just want to do an assignment. Something like if x is equal to 5, then assign this value over here. Otherwise, assign this value. Okay, so if all you want to do is assign a value, then you can reduce the code with an if-else statement. Okay, the if-else don't include like lines of code that need to be executed. But if you just need to return a value that gets assigned somewhere, then you can do that. Okay, but so this is a useful thing. Okay. Okay, let's we'll start talking loops. We'll run out of time, but we'll start talking loops. Okay. And I'm sure these were all covered in Stats 20, but I just want to say a few more things about them. Okay. So probably the most common use of the for loop we'll do for x in some integer vector. Okay, so you'll say like for x in 1 through 10, or I in 1 through 100, or 1 through 1,000, whatever it might be. Okay, and then you can execute some kind of line of code that takes each of those values, indices of I and the x, and prints this out. But the for loop will run over any kind of vector. It doesn't have to be an integer vector. This is probably the most common application, the integer vector, but you can give it any vector. So here I've got a list. How many things are in this list? It's a list of 3, right? I've got a numeric vector, a character vector, and a logical vector. And here it says for y in this list L, print out the length of each thing. So it's going to extract out the first thing in the list, which is the numbers 1 through 3, and it says the length is 3. Then it pulls out the character vector with the letters, and it says that length is 7, and pulls out this logical vector, and it says that its length is 2. So it doesn't have to be just for I in 1 through 100. You can give it any kind of vector, including lists. So here's an example where I've got a character vector with the state names Alabama, Alaska, Arizona, Arkansas, California in alphabetical order, and then it goes through each one, and it says for the first state, which is Alabama, in this vector, you know, print out how many letters that thing has, right? So Alabama has 7 letters, California has 10 letters, so on and so forth, and it prints all of this out. I'm sorry, not print, but cats. It cats it onto the screen, okay? Okay, it looks like we're gonna run out of time, but we'll cover all of this stuff on Friday, so we'll see you guys then, and you can look for the next homework assignment being posted very soon.